Welcome, everybody. It's great to have you all here with us. Today, we're excited with all of the things going on with Perc and with PTC these days. And so we're really pleased to be able to give you some really good updates today. I'm Joe Carella, and I the general manager of the CPG business unit. It's a business unit in the Focus Solutions Group division of the company. We'll talk a little more about that when we transition to Randy, and how the Perc product fits into the company. That hopefully will give you some confidence that the product is well cared for, and we have people 100% dedicated to making sure that it's successful and that your needs are met using real-time Java solutions. And just trying to, there we go. I just wanted to give you a quick update on the company and what's going on with PTC. Look, PTC's been around for a while, since the mid 80s. It started off as a CAD company, expanded into product lifecycle management, expanded into service lifecycle management, then into AOM and many other areas after that, including Internet of Things. Our ThingWorx product and platform for IoT came into being, that really moved PTC to a whole different world, where we began to manage the physical and the digital worlds together, and then introduced augmented reality products, and now are completely transitioning to a SaaS company. So as you can see, the market cap is very strong. Financials are very good. We're going to release our earnings actually today for our fiscal FY21 year that ended on September 30th. Of course, I can't make any comments about that until tomorrow, but you're welcome to listen to the earnings call at the end of the day today if you'd like. But generally, the company's in great shape. Obviously, we have a lot of customers here, well over 30,000 customers, ARR, annual recurring revenue of about $1.5 billion. There's 6,400 employees spread around the world. You can see between the Americas, Europe, and Asia, and have a good, diverse customer base. So if you look at the verticals in the bottom left, you can see that we have a healthy customer base in the industrial environments, high tech, federal, aerospace and defense, and automotive, and some in retail, life sciences, and others as well. The company continues to evolve as a disruptive technology solution for what the world is throwing our way. And let's face it, the world is throwing a lot our way. And through it, the company is continuing to thrive. I mean, there's people through the pandemic and all the technology changes, thrust upon us, that have not made it, and some struggling, many struggling. But PTC has been one of those companies that has actually thrived through all of it. And you can see here, we're looking here at the annual recurring revenue for each year. And you can see that it has been growing at double-digit rates. And we're actually looking for that growth to actually improve even further exponentially in the next several years, as you can see here by the chart I'm showing you. So we're really pleased with how strong the company is, how diverse it is, not just in its products, its customer base, but also its employees. And you can see that over the last several years, PTC has made a conscious effort to really get diversified in terms of sharing values together that are socially responsible, and also to make sure that we're including everybody to be a part of the success of the company. In fact, you can see here, we're gaining a fair amount of recognition by all kinds of places now, that PTC is just a great place to be part of. And so we're glad you're part of it. If you're not part of it, we hope you will soon. With that said, as far as Perc and what Randy will be talking about here for the rest of the call today, Perc is part of the Focus Solutions Group, and basically think of some developer tools that are really important, mission critical. As Randy will say, when milliseconds count, when milliseconds matter, it's like those are things that we have to really be focused on. It can't get distracted with all the new shiny toys that PTC comes out with. We want to take advantage of those new shiny toys, and when it's opportunistic for us to do so. Randy and I talk a lot about interacting with the IoT team or the AR team, typically the IoT team, to see if there's opportunities for us to leverage some of those new, cool, disruptive technologies, but we don't mix and match the organizations. So, we don't have to worry about the focus of Perc development getting mixed up and diluted with all these other new technologies that are coming out. So we're committed to the Perc product. We're committed to our customer base who uses Perc real-time Java, and we build them here in this group. We implement them, we support them, we do training here. All of the resources are completely dedicated, part of our Focus Solutions Group. And we're going to continue to leverage these resources and technologies to make you successful. We're very excited with the growth of, I talked about the growth of PTC, but Perc is a growing business for us. And we're really pleased to see the success that continues to gain momentum here in the marketplace, with this particular developer tool. So, at this point, I'll let Randy take it from here and tell you some exciting news and what's going on with the product and with the team.
Okay, thank you, Joe. And thanks and welcome to everyone who's joining us today on our Perc Update webinar. My name is Randy Rorden, and I am the Software Development Director for the Perc team. And Perc is, of course, as Joe mentioned, part of the PTC Developer Tools family of products. Let's see if I can jump ahead here. Hello, still trying. There we go. I'll figure it out. So our mission within Developer Tools is to provide world-class software development tools and runtimes to create robust, native, embedded, and real-time mission-critical systems. That's a lot of words. We'll talk about details in a minute. We do focus on being a trusted partner to our customers. As Joe mentioned, we're very dedicated to our specific area of the market and our particular customer base. We're trying to be responsive to their needs with product updates, training, consulting, and support. Within Developer Tools, here's some products that exist. They include a toolkit for Unix or Linux-like environment on Windows. There's an X server for Windows, a programming language development toolchain, an IDE for analyzing existing source code, and a UI toolkit based on X Windows and Motif. In addition to those, there are some Developer Tools products that are specific to mission-critical systems. That's Apex Ada and Object Ada that are there for developing Ada software. And of course, Perc for developing Java software for these mission-critical systems. So within Developer Tools, the Ada and Perc products uniquely target embedded systems. And it's important to understand how those systems differ from general purpose systems. General purpose systems have fast CPUs, large amounts of memory, and lots of storage. They run a lot of different applications, often simultaneously. They usually require human input and interaction, and they get turned on and off as required. In contrast, embedded systems are sized to meet a particular computing requirement for a specific application. They may have limited CPU or memory or storage resources. They operate within a larger mechanical or electrical system, and they're performing a set of dedicated functions, application-specific functions. They may not require any human input or limited human input, and they are often expected to run nonstop for years, literally years or decades in some cases. We often get caught up in the day-to-day work, and it becomes easy to lose sight of a bigger picture. And earlier this year, I was preparing some content for some short videos introducing PTC Perc, and I wrote down some keys to success for building embedded systems based on my own experiences and those of our customers. And you may have your own thoughts on the subject, but here's my list. The first key is to improve the pace and quality of your development process. This includes tools and practices and methodologies. The biggest challenge to this is overcoming inertia with your organization. The next is meeting your customers' needs. Now that's obvious, I'm sure, but many organizations fail at this. Everything you do should trace back to a current or anticipated customer requirement. Beyond fulfilling basic needs, you have to create an environment and have the ability to enhance your products, to delight your existing customers, to increase your revenues, and to find new markets. Next, recruiting the right developers with skills to create, maintain, and improve your embedded systems. This builds a foundation for future success. And of course, you must stay ahead of your competition. Falling behind means they'll start to take away market share, and eventually they'll replace you. Next, in today's embedded systems, I believe delivering digital transformation technologies, including IoT and Industry 4.0, is a must-have. You may think the IoT doesn't apply to your market, but I encourage you to consider what an upstart competitor might do to disrupt your assumption. And finally, you need to build reliable hardware and software supply chains to protect your products from part shortages, software obsolescence, and security vulnerabilities. This is becoming more and more evident as you see in recent news stories. These keys to success require constant attention and improvement to sustain your momentum. In today's world, customers prefer a partner over a vendor and an adaptive solution over a product. That means you're moving from, as our CEO says, from a place to a pace in your organization. So that's the top-down view of developer tools. Now let's talk about PTC Perc. If you have any interest in those other products in the developer tools portfolio, go to ptc.com/developer-tools, and you'll find them. All right, within the Focus Solutions Group, as Joe mentioned, the Perc Center of Excellence includes R&D, product management, QA, support, training, and consulting. We also have a sales account team dedicated to our products and to our customers. This gives us a lot of flexibility and a lot of focus that you would normally see in a smaller company. The team has over 20 years of experience in embedded systems with specific expertise in Java, real-time garbage collection, embedded Linux, concurrent programming, and compiler technologies. Here are some milestones in our history. They include the first release of Perc just 2 years after the original JDK was launched by Sun Microsystems. We updated to JDK 1.3 in 2001, then J2SE 5.0 in 2006, and we added multi-core support in 2010. Then Java SE6 came along in 2012, and along with the new compiler that was based on LLVM. In 2017, we moved to Java 8 and released our first 64-bit product. And in 2018, we added the ARM64 processor support. So over the last 3 years, we've maintained an annual release cadence, improving performance, ease of use, compatibility with the Java standards. And I know some of you are waiting to hear about the new features of version 8.5. I promise I'll get to that in a few minutes. We like to save the best for last. But first, let's talk a little bit about what Perc is all about. Perc is a clean room Java virtual machine. That means it's not based on a commercial license from Sun or Oracle. It's purpose-built for embedded systems, as I mentioned, meaning the design is targeted for that environment. It uses Java SE8 specifications and libraries, and it includes tools for optimizing and running Java applications under the Perc VM. And it's been deployed for over 20 years. So everyone's familiar with the benefits of Java. So I won't go into these details, but suffice to say, Java is very cool, very useful, very productive. I wrote my first commercial Java application in 1997. But traditional Java can't do real-time. Real-time systems have to meet deadlines from input to output, or performing a periodic task, or processing a stream of data with predictable latency. Missing a deadline is bad, and depending on the application, it may constitute a total failure of the system. Traditional Java virtual machines have unpredictable timing caused by stop the world garbage collectors, interruptions from JIT compilers, uncontrolled scheduling of threads, page faults, priority inversions, timing jitter, and object allocation delays, to name just a few. Here are some core features of Perc itself and how it makes Java real-time possible. A patented garbage collector relocates objects while Java programs are using them, eliminating stop-the-world pauses. An optional ahead-of-time compilation capability avoids JIT interruptions. The Perc VM Scheduler controls exactly when Java threads run, assigning them to a CPU core at an OS priority. The VM can lock memory pages into physical RAM to eliminate page fault delays. It uses priority inheritance protocol to avoid inversions. It supports a set of APIs to guarantee jitter-free timing, and it uses a deterministic memory management algorithm for constant time allocations. The ahead-of-time compiler technology, based on the same LLVM technology that's used by Apple's Xcode tools, generates native instructions from Java bytecodes in advance. The ROMizer tool will statically link that native code and class data from Java classes into a customized Perc VM executable. When that VM starts, the classes and the compiled methods are immediately available to the application. Alternatively, the Perc Accelerator, or PXL tool, performs the same AOT compilation, but it augments existing Java class and jar files with that native code. When a Perc VM loads a class dynamically, it detects the presence of the native code and links it into memory, bypassing the just-in-time compiler. These graphs are from the GC Stress demonstration program running on OpenJDK on the left and Perc 64 on the right. Both are running on the same hardware with CentOS 7 Linux. The GC Stress code is available on GitHub, and you can find a white paper about it on the PTC Perc homepage. But I'll give you a quick overview here. The red lines on the graphs show Java heap memory usage. The blue bars are delays experienced by high priority timing thread. With OpenJDK on the left, heap usage follows a sawtooth pattern. It's rising as objects are allocated and dropping when they are collected by the garbage collector. The maximum delay experienced by the OpenJDK side is 1.44 seconds. The largest delays, and those are the tallest blue bars on the left, occur 17 times in this 1-minute sample, corresponding to when the GC is performing a stop-the-world collection. So by comparison, on the right, Perc 64 heap usage climbs to about 300 megabytes and remains steady even as objects are allocated and collected. The worst case delay is 178 microseconds. That's not milliseconds, it's microseconds. That's about 8,000 times shorter than the OpenJDK worst case. It's true that most Java applications don't require sub-millisecond latencies, but your application may benefit from greater determinism. For example, are there places where a 1 or 2 second delay would cause your user interface problems, or message queue overflows, or repeating messages or transactions that were lost, loss of data, or loss of revenue? Would being able to set your Java thread priorities, knowing they'll be followed by the JVM scheduler, improve your system design? Are there scheduled tasks that would be more efficient if they ran on time without the effects of clock drift or jitter? And would the ability to AOT compile and link your application classes into a binary better protect valuable intellectual property? If any of these questions yield a yes or a maybe in your evaluation, perhaps you don't need a real-time JVM, but you could benefit from a deterministic JVM. Okay, now I want to take a moment and talk about one of those key successes or keys to success in embedded systems, namely digital transformation and industrial Internet of Things. A real-time JVM can be a game changer for IIoT solutions. Edge gateways have become an important part of smart, connected, distributed control systems. They are the quarterback of the network. They're pulling data from devices, aggregating that data and sending it on to servers, either on premise or in the cloud. And like a quarterback, intelligent gateways have the additional responsibility of making decisions to change a play based on what it sees on the ground. When a gateway detects an abnormal condition in a device, it can command a shutdown or other actions to save it from damage or failure. The Java language is great for gateways thanks to secure networking, concurrent programming, a wonderful ecosystem of portable frameworks and libraries. But a traditional JVM can't guarantee response to time-critical events. Perc offers the benefits of Java plus real-time response, exactly what edge gateways really require. The Perc R&D team coordinates with the PTC ThingWorx platform team to test ThingWorx Java SDKs and frameworks on the latest Perc VM. And we work with ThingWorx partners and customers to integrate the Perc real-time VM into their IoT solutions. All right, so here's a summary of the Perc tools and features. We have real-time response, Java 8 libraries, 32 and 64-bit products, multi-core and single-core support, AOT, which is ahead of time, just in time, and interpreted execution can be mixed. We support Eclipse as an IDE for debugging, for example, and we have visual tools and an in-memory virtual file system. So one of our visual tools we offer is PConsole, which is very much like JConsole, but with information specific to Perc. For example, it graphically shows when a Java application reaches near out-of-memory conditions, and it'll capture a Java stack trace to show where that happened. And data from the PConsole tool can be saved to a CSV file for later review, or you can look at it again in PConsole itself, look at it graphically. Okay, it's time to talk about Perc 8.5. The release on September 30th included both 8.5 for 32-bit Perc Ultra SMP and Perc 64 version 8.5. Both products support x86 and ARM processors on Linux. The release adds the latest OpenJDK bug fixes and patches to version 8, which includes support for TLS 1.3 in this release. The most notable feature of 8.5 is parallel AOT and JIT compilation and bytecode inlining. I'll talk about that in a little more detail in a minute. There's also a new internal mutual exclusion mechanisms for better performance using pthread mutex lock. We provide pre-accelerated Perc jar files with AOT code for each of the target platforms. And the Perc tools are now compatible with either Java 8 or Java 11. And similarly, the 32-bit tools can be run with either a 64-bit or a 32-bit JVM. Here's some additional details and the changes that were made to version 8.5. Previously, an array allocation in Perc was limited to 1 GB. Now we have full support for arrays up to the integer.max value number of elements, which means up to 16 GB for an array of type long. And of course, heap size limits also apply here. File paths may be up to 4,096 characters long. The PVM command line has a new option to set the inlining size, and you can set it to 0 to disable inlining. Also, the dump settings option on PVM displays the Linux signal numbers that will be used by PVM. That may be helpful for your debugging purposes. The ROMizer and PXL tools have a new option to control the number of threads that are used for parallel compilation. And the PXL tool now fully supports compilation of methods containing Lambda expressions. That was a feature we didn't have in 8.4, now it's there. So now it's fully up to date with ROMizer. There's more detailed output from the verbose progress option, and the number of ROMized classes is displayed at the output of the ROMizer. And if a ROMizer or PXL command terminates with an error, any partially completed output files are deleted automatically to avoid any later errors downstream. And lastly, the Perc Shell adds the -jar option that lets you launch an application under the shell, just like you would with PVM or Java. Okay, let's talk about the cool feature compilation and lining in parallel. So parallel compilation and lining allows the ROMizer and Perc Accelerator to use a set of worker threads to compile Java bytecodes to native code in parallel. The default number of threads is the number of CPU cores that are available to the tool. You can override this with the --AOT-threads option. The JIT compiler also does parallel compilation using a pool of available compiler instances. New instances are created on demand. Parallel compilation makes ROMizing and Perc acceleration and PVM execution faster. The implementation involved refactoring the LLVM compiler technologies, the source code for that, and the bytecode inliner to use per instance data rather than global data structures. It also meant using concurrency mechanisms to safely control when threads modify classes and methods. So how fast is it? Well, here's our screenshots showing 8.4 and 8.5 running a timed make fastJIT example build. Our customers know what a fastJIT build is. It basically ROMizes the kitchen sink into a VM executable. These examples were for an x86-64 PVM on an 8-core host system. So the new release is 7.2 times faster on 8 cores. And yes, it scales up with every core you get. So at this point, we want to apologize for shortening your coffee breaks when you start a build. Sorry about that, but couldn't be helped. Here's the cross Java version support feature for Perc 8.5. You can run the ROMizer, PXL, and other Perc tools using a Java 11 JVM from Oracle or OpenJDK. It works with Perc Ultra SMP tools and Perc 64 tools. We did this because the newer Linux distributions that are available are offering Java 11 JVM installations by default. So users won't have to look around for an older Java 8 to install just for your Perc development. And for this change, we refactored the Perc tools to eliminate dependencies on some Java 8 reflection APIs that were deprecated in later versions. And keep in mind that if you do use Java 11, Java C to compile your Java classes, you will need to set the boot class path and the source and target version numbers on your command line to guarantee that those classes will run on PVM. Next up, you can use a 64-bit JVM to build for 32-bit targets. We did this to support the general trend in Linux vendors moving from 32-bit to 64-bit OS and tools. And it's getting harder to find 32-bit JVMs these days, even from independent sources like Adopt OpenJDK. So the change was done by modifying the tools and libraries and supporting scripts to recognize when they're running under the 32-bit or 64-bit JVM and apply the appropriate commands and options for loading libraries as necessary. Here's the target system requirements for kernel, glibc, and GCC versions for each of the products and each processor under that product. These settings, these requirements haven't changed from Perc 8.4. So if you're using 8.4 now, you can switch to 8.5 with no change to your environment. So I found a roadmap slide from last year's webinar. I want to review it with you. So first of all, performance improvements that came along thanks to our parallel compiler. Cross-ROMizing from 64-bit to 32-bit targets, done. Ease of use thanks to things like Java 11 tools and pre-accelerated jars. We got our updates to OpenJDK patches and bug fixes. And we met the target release date. So kudos to ourselves, we did well. All right, moving on. Here's some of the things we'll be working on for the next release. We're going to be allowing the -XL targets for Perc 64 to ROMize more than 2 gigs of code and data. Up until now, the LLVM technology has been using what's called x86 small model, for example, and that limits the amount of memory you can use for your code and data to about 2 gigabytes. Now the XL targets will let you grow beyond that, essentially to the limits of your executable in your environment. We'll be offering secure remote communications to Perc Shell, thereby replacing Telnet, which is of course unencrypted communications. We'll be providing ANT scripts for the example builds. We'll be adding improved debugging and logging features to developers. This is going to be a really cool feature for folks who need to get into the details of what's going on in their application. Will be more ease of use improvements and more performance improvements as always. And of course, we'll update to the latest OpenJDK patches and bug fixes. And Perc 8.6, we're targeting for September 2022. All right, now let's turn some time over to Matt McDonald, and he'll talk about our resources available to Perc prospects and customers. Matt, take it away.
All right, let's get started talking about our resources. There it is. All right, so first we have plenty of resources available on the Perc webpage. This includes product data sheets, white papers, recent product release announcements, interactive demos, information request forms, videos of past webinars to watch, as well as all the features and benefits of Perc listed out. Also, all of these available resources, we have more customer resources, as well as the Perc installation downloads available at that developer tools link that you see. And now all of these Perc e-learning videos are available to all active Perc subscribers and support customers. As there it is, you can see that there. As well as these technical notes are available to help support you. So tons of resources at your disposal for Perc. And now I think we'll hop into the Q&A segment of today's webinar.
Well, hang on, before you go to Q&A, Matt, this is Joe. Can you go back to that last slide? Randy, this is a big deal, isn't it?
Yeah, it is. It's great. We've previously asked people to basically raise their support levels for those e-learning videos. Now that's available to all of our customers, all of our subscribers and evaluators as well. So yeah. Each of these videos is about 40 minutes. It's detailed product information about how to set up the product, how to use it, how to use the tools, how to configure Linux for your real-time requirements. And of course, that last tutorial on GC stress shows you how to run that garbage collector stress demo and confirm that things are working as you expect it to on your target system. Yeah. So really good stuff, and lots of information coming out. And we'll be doing more of these down the road. So
yeah, and we're really pleased to be able to make a shift here. Typically, these are the kinds of assets that we make available for our premium support customers. And what, at the request of Randy and Art and the team, they're asking that we make this available to all of you, all of our customers, provided you're active. If you're an active support customer or subscription customer, these are now part of your entitlement. You don't have to be buying any premium anything. Okay, so yeah. Good move. I'm thrilled that we're able to do that. Okay. Man.
So a question came in that Art noted just arrived, and the question is: we use Red Hat OpenShift for containerization, and is Perc performance impacted? And great answer. In fact, if you, Matt, if you'll go back to that slide again one more time.
Right.
So that last technical note on the very bottom, the fourth technical note there, running Perc 8X in a Docker container. And OpenShift or any container system is supportable with Perc. There are some command line options you need to set when you start your container up with your image containing Perc, so that you get real-time response out of that container. But by virtue of the way containers work, it's just a namespace and specialized access to the kernel, but it's still processes and threads, and you can get real-time threads running in a container just as easily as you can do it in a standard process on Linux. So I hope that answers your question. If you have more, feel free to send an email to developer tools support. So developer-tools-support at ptc.com, and we'll get you a more detailed response.
I think we have a few more questions.
Okay.
How is Perc licensed?
Yeah, this is something that we leave usually to our account representatives, but I'll just give you the broad strokes. So there's what we call a Perc PAL subscription license. PAL stands for Project, Architecture, and Location. And that means, your particular project, your particular architecture, x86 on Linux or x86 64 or ARM 64. And of course, your location is part of that subscription license. It authorizes you to use the development tools by the customer for a given project at a specific location for a specific architecture. And there's a number of developer seats. There are floating seats for concurrent use associated with that license. That subscription includes support, of course, and it includes maintenance updates and minor version updates. So if you have Perc 64 version 8.5, for example, under your subscription, that entitles you to upgrade to 8.6 or 8.7, et cetera, without any further cost to you. Perc also has runtime licenses required for deployment. The runtimes are perpetual, and they're purchased by CPU core count usually, but we can talk to you about how that works for you. The runtime license gives you the right to deploy the Perc virtual machine and the runtime components of Perc with your application. And you can go to the Perc homepage and click on the Contact Us button to reach an account representative and get more information about pricing, which I'm completely unable to talk about because I don't know it. Well, yeah, so that's the gist of how it's licensed. So you got a subscription license for the seats and the general ability to use the product, and then there's runtime licenses, which are perpetual.
Right. And will Perc support versions of Java beyond Java 8?
Oh, great question. We're investigating that possibility. We would be looking at Java 11, and of course, if we did something for that, it would be called Perc 11, because we're matching up to the version number just to keep people from getting confused. We aren't ready to commit to that yet. There's a major obstacle in getting to anything past Java 9, and that is it's called the Java Platform Module System. It was introduced with Java 9. Java modules are great. They group names of, they have a group and name them with a set of packages and resources. So it's a kind of a super package kind of concept within the Java language specification. And it specifies the modules that it depends on and what packages that it makes available to other modules. It can hide packages within the module, of course, and keep them local to that module so you can't reach them. It's a very nice feature of Java, but it does cause some headache and heartaches for people who are migrating from Java 8 to Java 11, for example. It requires you to adjust to that new module system. There are some third-party libraries out there and some frameworks that won't work with Java 11, and others that require you to get a new version of their framework to work with Java 11. So there are some issues there, and there are some internal packages in Java 8 that aren't accessible anymore, so it could very well affect your application. If you're interested in a Perc 11 and the concept thereof, feel free again to send an email to developer-tools-support@ptc.com. We'll talk about your specific interests and needs and keep you updated about our efforts.
Are all Java 8 libraries supported?
Yeah, pretty much. I will mention just a couple of exceptions to that rule. So we use the OpenJDK sources for our general libraries. 99.9% come from OpenJDK. There's a few core libraries that are ours, stuff that has to be aware of the Java virtual machine, which is ours uniquely, not hotspot. And so there's a couple of exceptions, though. The Java Lang management classes that do things like let you look at status and information from the hotspot memory management system, or from the garbage collector, or from their compiler. Those MX beans are called manager MX beans. They're not fully implemented because they're not applicable to the Java virtual machine internals. Also, the SOX proxy protocol, which nobody ever uses in JavaNet socket, those aren't supported. And socket methods for sending out-of-band data are not supported. Another area of interest sometimes, the Java FX graphics library, that's not included with Perc, but you can download it and build it separately and run it on Perc if you wish. And full AWT swing graphics are fully supported.
All right, and one more here. You mentioned some new timing APIs. Are they part of the standard Java libraries?
No, they're not. Unfortunately, Java and the Java libraries only provide timing systems, timing APIs based on relative sleeps and waits, so relative to your current time. And that can be problematic to avoid jitter or clock drift. We have a set of deterministic timing APIs that are very similar to the standard Java APIs, and we provide them and document them to our customers. So for example, everyone's aware of thread.sleep in Java. We have a sleep until that says wake up when this particular moment in time in the absolute uptime of the JVM is reached in nanoseconds. So there's an absolute uptime API. You can say, what's my current uptime? Now add 300 milliseconds to that and sleep until then. And so you can get a wake up occurring exactly on the time you specify as opposed to relative to current time. That's very helpful. We also have an object.wait until equivalent. So that does the same thing for waits as it does for sleeps. And we have documented versions of the Java util timer class and associated classes like timer task that use the wait until mechanism to implement a jitter-free periodic timer, for example.